Good morning, everyone. My name is Benjamin Kong. I'm a fourth-year mechanical engineering student.
And my name is Tegan Barnes. I am a third-year mechanical engineering student.
And we are part of the senior design team for Solar Decathlon. Outside of the senior design team, we call ourselves Team Orange County, and our house is named Casa del Sol. So some background, Solar Decathlon is a competition where 20 collegiate teams come together and we build energy-efficient, zero-net energy homes that are solar-powered. Each home is judged based on 10 contest categories, some of them which are measured and some which are juried. An example of one that is measured is our energy balance. So we have 175 kilowatt hours over the span of 8 days. And other examples are, we are also judged on architecture and communications as well. So basically the goal is to win the Solar Decathlon competition, which is coming up in October of 2015. So here's a video clip to kind of give you a better idea of what Solar Decathlon is. Unfortunately, the speakers don't work, so you'll have to kind of listen through the laptop.
We need to out-educate, out-innovate, out-build the world. That's where you come in. The University of California, Irvine, Chapman University, Saddleback College, and Irvine Valley College.
So Team Orange County consists of 4 colleges, UC Irvine, which is in charge of engineering and project management, Chapman University, which takes care of our communications and marketing, IBC College, which takes care of construction and technology, and then we have Saddleback, which is taking care of our architecture development. Within each of those schools, we're actually broken down into different work groups. For UCI, we have 1 electrical engineering team, we have 2 civil engineering teams, 1 mechanical engineering team, and then 1 3D printing team. So specifically for the mechanical work group, our goal is to lower the energy usage and energy demand of our home. The ways that we're thinking about achieving that is to design an efficient building envelope in order to lower the energy demand, and then to design an efficient HVAC system, which is heating, ventilation, and air conditioning, to lower our energy usage. And so you can see from our energy budget, HVAC actually takes up a pretty huge portion of our energy consumption, almost about 30%. This is a rough timeline. We basically just completed 95% of our design and we submitted that to the U.S. Department of Energy. And now we're going to begin construction at Irvine Valley College. And in the meantime, we're also going to be working on value engineering and optimization of our systems. In terms of budget, our fundraising goal is to raise $1 million, and we're pretty much well on our way. We have some pretty big name sponsors such as Edison International and SoCal Edison and Irvine Company. For the mechanical team itself, we have a budget of $30,000, and we're looking to spend maybe about $15,000 to $20,000 on our home for our HVAC system. So the design process. First, the building envelope is the outer layer of our home. It consists of the walls, the floors, and the roof, including the windows and the doors and such. So we had a really iterative design process for that. In the beginning, we had a team of architecture students kind of compete in a small competition to build designs that would incorporate passive design techniques such as taking advantage of natural ventilation and shading. And then from that competition, we would pick a design and then kind of throw it into energy modeling and do building load calculations and then make further changes to the home accordingly.
All right, so we started off with a design envelope, and what we've been recently working on is our HVAC system. We've been working pretty hard with that with an engineering consulting firm, McFarland Associates. So at first we started researching absorption chillers, mini split heat pump systems, radiant systems, a whole house fan system, and we modeled these in IESVE engineering software. Because we were at a time constraint, we were able to model mini split heat pump system and the whole house fan system, but we ended up choosing the radiant system because we are on an energy budget, and we just did the down selection process in order to get to that point. So this is a model of our HVAC system. It consists of 3 storage tanks, a 750-gallon chilled water tank, a 140-gallon hot water tank, and a 120-gallon regular hot water tank that's going to be connected to the solar panels. So we have evacuated tube collectors that will come and bring in hot water for the day. And then the hot tank is going to be 180 degrees Fahrenheit, and that's going to be innovatively connected to a preheat tap that will be going to our kitchen, because we do have a cooking competition and a boiling competition to be able to boil water within a certain period of time and evaporate it. And then we also have that hot water at 180 degrees going to our dryer, and our dryer is the first Energy Star dryer that is connected to a paraffin tank, because the paraffin will be able to absorb the heat and keep it at that level to dry the clothes within a certain amount of time, and not be able to, and use half the amount of energy that is required normally for drying. We have a water-to-water heat pump, and that will be used to cool the water for the chilled tank for the radiant system. And also on days where it is not too sunny and we don't get to the temperature we need to for the hot tanks, to get it to be at the temperature it needs to be. Any excess heat will be going to the radiator. Here is a plan of the ventilation system. We will be having controllers for the windows to help with ventilation throughout the conditioned space of our home. So here are the 2 bedrooms, the kitchen, and then a studio apartment room. So the summary of what we've done so far is completed our 95% design and built our HVAC and building envelope. So far we have that model, but we need to work forward to see how it works just actually all together as components, and to optimize the system, order the parts, and start construction on the home. Here are renderings of the home itself, just our initial ones, and as we've worked with other professional companies, how it's gone to this point. You can see it's very open to accommodate for our narrative. So for the competition, we have to decide what narrative we want to set for the home. So we've decided to choose the Southern California, Orange County climate, and that's why you see the movement of the home in its open spaces. Here's a little fly-through of what our home looks like.
Orange County's Casa del Sol is an innovative, net-zero energy home that draws inspiration from the California state flower, the golden poppy. This California state flower opens and closes as it adjusts to the light of the sun, a method emulated by Casa del Sol in order to promote the indoor-outdoor California lifestyle. Passive solar design uses appropriate shading and natural ventilation to allow our home to open and close to the sun. Thanks to this flexibility in design, the walls can also adjust in order to change room size or quantity, thus allowing for multi-generational living or a possible rental. Team Orange County's home addresses ecological concerns and helps meet the need for affordable housing in Southern California. Our modern design makes a sustainable future feel like home.
All right, that is our project main gist. Do you guys have any questions for us?